Okay, fourth year, so I'm introducing pneumatics to you, and we've talked about the basic components. So we started off talking about the cylinders and trying to get these diagrams correct every time. Single acting's got the spring in it and only one port. Knowing the difference between main air and exhaust. So main air is the air that comes from the supply that's used to make cylinders move, and exhaust is the idea that we let air come back out into the atmosphere. I had asked people to do descriptions of these, and the idea was that it's pretty simple. As soon as you build that circuit, that will outstroke, and it will stay outstroke because it's got a main air symbol on it. There's no control of the cylinder. Same here, as soon as you provide that main air signal to that cylinder, it will outstroke, and that's it. And any air on this side will come out that port there. And then here, this was the double acting cylinder with the two main airs at either end. And the initial expectation is that the double acting cylinder would stay static, but the reality is because the areas are different on either side of it, then the force generated by the same air pressure will be larger on outstroke, so it will actually very slowly outstroke. The way I've drawn this, I've shown two different main air symbols. I could equally have drawn the double acting cylinder like that with the two ports on it, and then one main air symbol coming up to a kind of bold black dot there that we would call a T-piece. Okay, so that's the same. These two things are exactly the same. That's main air supplied to both input and output. Right, so that's what we talked about in terms of cylinders, and then we talked about the 3-2 valve. A couple of mistakes that people were making. That arrow maybe wasn't there, or it was pointing the wrong way. That arrow, I've just realised I've told somebody to do that the wrong way in their feedback. Sam, I've told you the wrong thing. That arrow should be pointing down and to the left. Should be pointing from the output port to the exhaust port. Okay, so that's the symbol for a 3-2 valve, and that was the symbol for the actuators. And then I had and most people managed to get this bit right. You know, they named that plunger, spring return, foot pedal, spring, diaphragm, roller, lever. It's important to note, same lever, where they talked about that. And then they drew them correctly as well. So well done. So before I go any further, I was going to show you some of these rather than just showing you the symbols. Show you some of the real ones. Oh, I'm all big now. So here is a single acting cylinder. You know, as much as we're not going to do the practical, we might try to do the practical when we get back, obviously, if we've got time. So there's a single acting cylinder. There's the piston rod sticking out. It's currently in-stroked, obviously. You can see the port on the back end of it where we would plug the hose in. You can see an empty hole in the front because obviously there's still air inside that cylinder that would have to come out whenever we outstroke it. So you can see that if I were to put air in there, the piston rod would come out that way. And if I let it go, it springs back in. Sometimes that wee hole has got a port screwed into it and it looks like it's got two ports on it, so you might think it was a double acting cylinder. The only true way to tell the difference between a single and a double acting cylinder is to grab the piston rod, pull it out and let it go, and if it jumps back in on its own, it means it's got a spring inside it and it's definitely a single acting cylinder. Whereas a double acting cylinder is a bit dumber. So there's a double acting cylinder, it's bigger, you can see the two ports on it, and in this one, if I pull the piston rod out and let it go, it stays out. There's no spring inside there. If I want that to move back in, if I want it to move out or in, I need to use air pressure, and that's why it's called a double acting cylinder. Double, because it's out and in. So that's the two cylinders that we use. Single acting cylinder and double acting cylinder. One of the tasks I'm going to ask you to do is to sketch it. I want you to sketch the single acting cylinder and label it. I want you to label that this guy here is the port and that this guy out here, he's the piston rod. So task one is going to be to sketch these components that I show you. So you'll have to pause the video and get a look at them. Right, so single acting cylinder, double acting cylinder with the two ports sticking out, so I don't want these things in the way, don't want them to confuse you. Back a wee bit. So you can show it in stroked with the two ports, port 1, port 2, these bits sticking up, that's the port sticking up there. You might refer to that as the in-stroke port, because when you apply air pressure here, that's going to in-stroke the cylinder. You refer to that one as the out-stroke port, because when you apply air pressure to that one, the cylinder will out-stroke. Okay, so sketch that one and label it. I'm going to want to see these. Do them clear, do them carefully. Here's a 3-2 valve. So that's what a 3-2 valve looks like. Remember, it's called a 3-2 valve because it's got 3 ports and 2 states. But you can only see 2 ports on it. And I did reference that in the video, the idea that the third port, the exhaust port, just exhausts back to the air, so you don't actually have a connection for a hose on there. The exhaust ports are those wee holes in the top of the body. You know, I can see them on the screen there, so you guys should be able to see. There's 2 wee holes. There's one at my index finger, and there's one at the other side. So, yeah, that's the input port there, and that's the output port there. And this is a push button spring return 3-2 valve. I push that button, that's me connecting the input to the output, and if I let the button go, the spring pushes it back up and disconnects them. That's a 3-2 valve push button spring return. I would like you to sketch that one and label it as well, please. Another really simple component that we've used in our bag of tricks here is the wee T-piece. So that's just an unintelligent component that allows you to turn one hose connection into 2 hose connections. So wherever you see a black dot drawn in a pneumatic circuit, it's a T-piece. Alright, you can sketch that. There's not much to annotate. I'm going to show you another 2. I don't want you to sketch these, okay? I just want to show you them out of interest. So these are 3-2 valves with different actuators on it. The first one I'm going to show you is the diaphragm valve. So this is the diaphragm valve that we use. Like massive, it's really heavy as well. So diaphragm valve, a diaphragm is a word that's used to describe something that's like really thin, stretched, and has an elastic kind of property to it, right? So you might have in biology talked about the diaphragm in your chest cavity that helps you breathe. This is a diaphragm in here. That black line that runs across it, that's actually a piece of rubber, circular piece of rubber that's trapped really tightly. See all the screws on there? It's trapped really tightly in between these 2 bits of metal, so it's basically a skin of tight rubber in there. And if I apply air pressure in here, that piece of rubber will start to deflect, just like blowing up a balloon. Yeah, it'll start to inflate and a bit of rubber will start to push down. And we can use that physical deflection to change the 3-2 valve. So this port on the top is actually to give you an air pressure signal to the diaphragm. And then the ones on the bottom, you've got input and output. Yeah, so in this state, the input isn't connected to anything, and the output is connected to the exhaust, which is a hole on this side here. And then if you provided air pressure there and the diaphragm were to deflect, suddenly the input would be connected to the output. So that's how we can create like controllable airflow with these valves. That's what they're for. We make sure that the pressure that's applied here is never main air, because if you put main air in there, chances are you would burst your diaphragm. You don't want that, right? So that's a diaphragm spring return 3-2 valve. No need to sketch it, I think that would be quite difficult. And then the next one I'm going to show you is a solenoid 3-2 valve. There's a solenoid with the 2 wires coming out of it. Okay, and you can see the 2 ports, input and output. I can't remember what one's what. I think that's the input and that's the output. And I'm not sure where the exhaust port is on this guy. It might be inside that plastic housing. Can't really see it. So not much to look at in this one. You just got these 2 wires. So basically if you provide, I think it's a 12 volt solenoid. So if 12 volts is there, then the valve is open. If 12 volts isn't there, the valve is closed. Again, no need to sketch that one. So I just want sketches of single acting cylinder, double acting cylinder, not the symbols, the actual things. If you want to draw the symbols next to them, that could be a good idea, so that I know what one you're trying to draw. And one for a push button spring return 3-2 valve, and if you want the T-piece as well. So that's what the real symbols look like. We're going to move on a little bit here. Try to shrink myself down. I'm melting. Right, so what I would like you to do for the remainder of this lesson is create some circuit diagrams, okay? So I'm going to give you like a written challenge, a written brief, we'll call it. I'm going to give you a brief. Let me give you 3 briefs. Okay, so number 1 will be, in fact I'll pause the video and put them up, give me a wee second. Right, okay, so the 2 questions are: create a pneumatic system which is used to lift and lower a dentist's chair. The dentist should be able to control it with one single button. Bear in mind that it could be used to lift really heavy loads. How do you think you would design a system that was, what kind of things would your system, your pneumatic system, have to have in order to lift something that was really, really heavy? These answers are based only on what has been in the presentations so far. No new information is required. The second one, create a pneumatic system which is to be used to raise and lower a car park barrier. The attendant should be able to operate the barrier with an up button and a down button. There should be 2 buttons. For both of these, what I want to see is a heading, so dentist's chair, and then I want to see a circuit, and then I want to see a parts list, and then I want to see a description of operation. Okay, so let me give you an example. Right, okay, so create a system which is this is the example. You might want to copy this down and do this, okay? So it says create a system which is to be used to open a safety guard on an industrial sewing machine if a foot pedal is pressed. The guard should lower again if the pedal is released. So there's only, right now at this stage, we've only got 3 components that we can use. A 3-2 valve that's got different actuators on it, a single acting cylinder and double acting cylinder. You need to figure out which of those we're using. Now, it says that there's a foot pedal. It doesn't talk about any other actuators. So it looks like there's only 1 valve here. So that must mean that we're only using a single acting cylinder. So this system is going to be based on a single acting cylinder. Let's try to draw it a wee bit neater. So a single acting cylinder. There you go. Don't know how I'm going to do my zigzag neat. I wonder if I could. There's a zigzag there, look. I wonder what happens if I use this. Oh, you beauty. Can you just go down here? That works out quite well. Yeah, that works out quite well, doesn't it? And that'll do. Call it quits at that. And then I need my port on there. So I've got a single acting cylinder. We'll cut and paste that because that's handy. And then a foot pedal is pressed, so that's going to be a 3-2 valve. Again, let's try to draw this neat. I'll just pause it and draw it dead quick. And it's got a foot pedal on it. I know that. Right. And I know that the output's going to be connected to the single acting cylinder. Now, we haven't used these yet. We haven't actually drawn a circuit yet. So this is the input port. That will nearly always be connected to main air. Nearly always. And then that's the exhaust port. That is nearly always, in fact I think it's always connected to an exhaust. So we always have to add something onto these D2 valves. We have to add an output and an input and an exhaust. Okay. So if the person presses the foot pedal, the main air signal will outstroke this bad boy. The guard should lower again if the pedal is released. So if you take your foot off that pedal, what makes it return? It doesn't tell you. So it's natural to then assume that it must be a spring. So we've got a foot pedal, spring return, 3-2 valve. If someone presses the pedal, main air will outstroke the cylinder. If they let go of the pedal, the spring will push it back. Main air will be removed and the cylinder under the action of the spring will instroke again. There you go. So that's my circuit drawn. And then I'm going to give a parts list. So the parts list will be single acting cylinder, times 1. Correct name. Foot pedal, spring, 3-2 valve times 1. That's it. Go parts list here. And then I want you to include a description of operation. Now I've already said it out loud as I was doing it, but I would want you to type it. Well, I would want you to write it in some way, okay? You don't have to type it, you can draw it in your jot or whatever. You need to make sure this stuff's neat and tidy for me to be able to read, otherwise I won't be able to understand it, right? So, when a user presses the foot pedal, the 3-2 valve will provide a main air signal to the single acting cylinder. Let's make that a lowercase s. Outstroking it. When the user releases the foot pedal, the 3-2 valve will deactivate and the single acting cylinder will unstroke. Yeah, that would be enough. We don't necessarily have to talk about the spring returning or the exhaust port, but we definitely have to talk about the valve actuating and deactivating, the cylinder instroking and outstroking. What makes it outstroke, what makes it instroke. That's what we want to see in these simple descriptions. So I want you to go ahead and do that for those 2 questions there. So I'm expecting to see sketches of those 3 components, maybe even the T-piece annotated, and then I'm expecting to see headings, circuits, parts list and description for these 2. Okay, go ahead and do that now.